So I'm Chad Furman. I'm product manager on the Ansible BU in charge of controller and edge. Hence why I'm here, but I guess more importantly why you want to listen to me talk is I was enterprise architect at ExxonMobil before I came to Red Hat 2 years ago. I also worked for DoD for a little bit and did 15 years in retail. So I've done edge and a good chunk of the retail, a good chunk of the different industries out there. Now I'll let my counterparts here introduce themselves.
How you doing? I'm Roger Lopez. I'm part of the technical marketing team. I've been doing the Ansible, been part of the Ansible BU now for a little over 2 years. Mostly doing awesome stuff with Ansible. Lately, I've been doing stuff with Ansible and OpenShift, and today, doing a little more of this industrial edge stuff.
I'm Adam Miller. I'm part of Ansible Engineering. I lead the Edge engineering effort.
Short and sweet. That's what I always like about Adam. He acts like he doesn't do a lot. He does a lot. All right. So first off, I'm just going to give. Well, I'm going to make this interactive because I mean, as much as I like to listen to my own voice, I like to hear your guys' voices better. Does anybody here not know what Ansible is or want to run through of how Ansible's set up? Raise your hand if you don't know what Ansible is. Let's go with that. Okay, that's good. Then I will do a quick introduction. So Ansible is literally built for scale, and this is the Ansible Automation Platform 2, where we took the old tower and really decompiled it and decomposed it to make it much more scalable. Now you can actually take things like your execution plane, and it's not all reliant on one server to do everything. You can actually, I was talking to a customer earlier, it isn't in here, but he was telling me he has 17 different execution environments into different meshes globally around the world, just so he doesn't have to have execution happening in a central location. So definitely look into that if you haven't looked into the way the meshes work and how you distribute out the execution plane from your top level UI. It's a huge mess. It's just a massive improvement. And I came from somewhere where we were doing this at a very, very large scale, running everything on, well, it's, simple math of how computers work. Running a bunch of stuff in one place, not the best plan if you have a whole lot of it. So distributing out that execution workload is huge. Quick agenda. So we're going to do, of course, a little intro to what industrial edge is, challenges of OT automation, which I would like that to be a bidirectional conversation if we can, because you guys' challenges are the things that I want to try and help you guys solve. A little bit about our enterprise edge automation that we've been working on, collection that we actually worked with some of our friends that are in the audience today to actually how to manage programmable logic controllers with Ansible, which was huge and something I never thought would happen and is really cool. And then get into real world applications, because as much as we want to talk about bits and bytes all day, what problems do we help you guys solve? So, quick intro. What is the industrial edge? It's literally everything that you use to manufacture things. It's the things to build electronics, things from chemical companies to pacemakers to everything you buy. There has to be a computer these days that actually manages it, whether it's a little tiny computer that's doing ladder logic all the way up to how are you doing AI and data analytics, and how do you actually push those AI models, train those AI models, and distribute them out. It's much more than this, and we could probably have a whole conversation about what this is, but this is what we're seeing on the industrial edge today. Adam?
Yeah, sorry. I threw this slide in about half an hour ago because I went over to our Edge booth and took a few pictures. So we're doing live demos of actual functional equipment in our booth space. So we have a beer bottle assembly line that's kind of showing off a handful of things, as well as a partnership with Guys AI, where we're doing computer vision to identify, do basically quality assurance on the production line of beer bottles and the application of the labeling. And then yeah, we don't have I don't know. I'm not from Massachusetts, so I don't know what the local thing is, but where I'm from, it's TABC license. We don't have one of those licenses. Anyways, so all this was automated with Ansible, and then Guys AI is providing the computer vision and the AI componentry there as a partner. And then on the left here, we have, with Schneider Electric and Intel, we're showing off a full cabinet of equipment where we're doing, we're doing a bunch of stuff over here. So there's a water pump station, I believe it's water filtration as well, and then you can actually pull any of the redundant nodes out that you want. You can pull the entire compute node out and plug it back in, and you can actually go over there and they'll let you do this. You can actually just yank it and put it back in, and when it gets put back in, it sends an event on event bus. Event-driven Ansible, which was announced yesterday morning, will actually pick up that event and will re-provision that device from scratch, and it will actually get a brand new everything. All the full config, everything is put back in place, and then it will rejoin the fault-tolerant high availability. So I just want to show those off. Please go check it out. Yank the thing, flip the bits, do the thing, and get the opportunity to actually see this stuff in real life. Because watching slides is fun, but seeing it actually function and see where the application could go is, I think, considerably more useful and typically a better experience. So, all right, I'll hand it back. Sorry.
It's all good. I think we've all done our fair share over the past 3 years of watching slides on screens. So now we get to do it in person. Wait. Uh-oh. Okay, so industrial edge examples. So everything from your endpoints down to your distribution, your substations. If you're talking about electrical distribution, we're actually working with quite a few electric distribution companies right now. Plants, data centers, line servers, all of the different pieces, but a lot of this is still traditional IT. And when you're talking about kind of in-between edge of like, is it a far edge device? You're still probably going to be pushing that into some sort of virtualization center, some sort of application layers that you're having to doing. Everything where I came from ran through SAP ERP, so there's generally some SAP tagged into here. So a lot of the things that we already know from an IT space is bleeding over into that industrial space. And this is cool to me because I love both sides of the coin, but it's nice that we're actually like seeing real world application, because at the end of the day, Linux is awesome, but seeing Linux do cool things is way more cool to me. So Edge is bringing the transformation over to OT. A lot of people will call this IT-OT convergence. Some people don't like that, the way that that's stated. A lot of people say that OT is taking all of the best practices from IT and applying them to the OT space. And I think that's actually fair, because OT has a lot more things that they have to think of, because if you make a bad decision in a data center, there aren't necessarily lives at stake. And I think that's super important to think about when you're thinking about OT, because if you spin a motor too fast, or if you do things on a substation, if you change the electric on a train, that is people's lives that are at stake. So it's extremely important to think about software secure supply chain and things like that. That applies very heavily here, because whatever happens there, someone's life could be at stake. Not to bring down the conversation, but it's very, very important. All right. So business requirements and all of the things in that space. I'm not going to read this out to you, but if you're thinking about how you're going to be running all of this, you heard about Lightspeed, you've heard about AI, we've all been talking about ChatGPT ad nauseum for the past 6 months. How do you actually take those models and train them? How do you take those models and distribute them and pull the data back, visualize that data, and get all of the things that you want out of those analytics? Because at the end of the day, you want to be able to make good decisions. And that's what a lot of the edge is pushing that decision making further to the edge, but then being able to apply the different models to it, and then again, make changes, make differentials, and then push that back out and pull it out and get to a point where the AI is smart enough to do the things you need it to do. All right, IT-OT convergence, more slides. I'm not going to read these out to you because I don't like it when you do it, but the big ones are on the sides. Strong secure access, industrial control process and business flows, gathering that data at scale to make decision making, so whether it's industrials or retail, real-time analysis and action. So getting to that point where, like in the guy's AI model, it's looking at a bottle and saying, oh, this label's on here wrong, the top's on wrong. This silicon wafer that we just pushed through a manufacturing facility that has flaws in it, throw it away. That's been a manual process for a long time. But now, I was talking to a car manufacturer the other day, and they have 20,000 Raspberry Pis running little cameras that just watch the entire part of the assembly line. And then consistency. And I think that's where automation really comes into this space, is being able to consistently configure all of those different 20,000 Raspberry Pis or whatever it is that you're running in your manufacturing site, and have them configured the same every time securely, lifecycle manage them, lifecycle the application layers on them. That is not easy. It's easy in a data center-ish. It's real hard when you're talking about really bad, inconsistent network connections. Who knows what the Purdue model is? Okay, for those who don't know what the Purdue model is, this is what we have used for a very, very long time in the industrial space. And a lot of people will tell you never the two shall meet between any of these different layers of the model, but I have seen some really nasty things done with the Purdue model over the years, and I see people smirk because they have also. But I don't necessarily see this model going away. I see it evolving quite a bit, but most people, to explain it from like the bottom up, nothing from the bottom will ever talk to the top. And in order to get the things from the bottom to get to the top, there are multiple layers of firewalls and configurations and things like that. And if you start talking about things like zero trust networking, that gets really, really complicated really fast. And how do you configure that and make sure that all of that is done in a proper way? And of course, audited. And whenever the auditors come in and look at it and say, are you actually not letting layer 2 connect to layer 3? That's not the easiest thing to prove, especially if they just ask for your firewall logs and all of a sudden they see traffic traversing it. Not that I've ever seen this happen before. So automating all of this is extremely, extremely important, but this also applies to things outside of just like manufacturing, because telecommunications at the end of the day is needed to talk to those manufacturing facilities. We're seeing a ton of work right now in private 5G, which, by the way, another plug for the Edge booth. We actually have private 5G hooking up everything in there. So we worked with Verizon to set up private 5G for the entire Edge booth, and it's pretty cool. Go check it out. Energy, oil and gas, of course, all of this. I came from oil and gas, and before I worked there, I didn't know that oil and gas wasn't just pulling oil out of the ground. There's a whole lot more to oil and gas than just pulling oil out of the ground. Is all the things that they make out of the oil and sell to us, like plastics and isopropyl alcohol, that is actually how they make a ton of their money. All of that requires all of these different pieces to work together. Who gets this one? All right, Mr. Lopez, your turn.
Give Chad a few minutes to rest over here. Basically, I'm going to talk a little bit about introducing Ansible Enterprise Edge Automation. To give a little bit, we think about Ansible as a universal automation language, and really what that means is that Ansible is really good at managing all sorts of different technologies, and it makes it easy where essentially it's your translator between various technologies and protocols. So in the perspective of what we're trying to do here today, it's like not only from being able to, let's say, manage infrastructure, but also being able to manage different like programmable logic controllers via the common industrial protocol, right? So we have that flexibility with Ansible, not only to do infrastructure, but do things like programmable logic controllers. Yeah, I know, it's kind of hard. It's like I kind of want to just say like like one too many. So here we have a slide basically on the flexibility to scale. This is actually a world picture. I don't even know if you can see it that well, but basically it's kind of faded here on the slide. But effectively what you're looking at here is you're looking at different Ansible automation platforms that are all in different regions, all talking to basically different edge execution nodes, essentially. And one of the things that Ansible Automation Platform introduced this year with version 2 is the ability to do automation mesh. And automation mesh allows you to easily scale by basically decoupling the control plane and the execution plane. And effectively what it does is it allows us to bring automation closer to what you're trying to actually automate. So in this case, you're trying to automate edge devices, right? So when we look at it from the perspective of Ansible, what we're trying to do is it makes it easier whether you're trying to do core data center, or you're trying to do distributed edge, far edge. Ansible can access or be able to access any of those devices wherever it is on your networks. Like that's kind of one of the big selling points with Ansible and with the ability of using automation mesh that gives us that capability. And here, lastly, for me, I have basically this slide on, when we think about Ansible Automation Platform, we have so much content available that's not only certified but also supported. We have 140 plus certified collections, 55 different technology partners, And I think the big thing to bring out of that is basically really realizing that Ansible's ecosystem is very large. We have so much content that's available, and it's going to help you accelerate whatever it is you're trying to actually automate. So that's kind of one of the points. It's not just about the technology, but the ecosystem around the technology that's being built out. And with that, I'm going to pass it on to
Okay, really quick. So I wanted to touch on one thing that actually both Chad and Roger touched on was number one, the Purdue model. Number two, the scale out. So we have the automation mesh, and the thing that's interesting about the automation mesh is it can handle unidirectional traffic. So egress versus ingress. If you have a networking policy to where you can't allow an ingress on something, you can actually have that execution node reach out and check for work. And it will maintain that over time. So you will still have a push model from the controller. The controller will push work out to the mesh, and then the mesh will handle the traffic from there. And you will be able to have each component of your execution environment mesh throughout the chain model its own traffic as required by your network segmentation policies. Okay, so jumping into the implementation of this stuff, and for me, this is the fun bits. And so, as mentioned before, or maybe it wasn't. This is a tagline that I like to say a lot. But Ansible is a universal automation language, and what I mean by that is it can become the lingua franca of your ability to automate literally anything that can talk over a network protocol. It doesn't even have to be IP, and this is what's been very interesting in this work that we had the opportunity to do is we are able to bridge the gap between older technologies and newer technologies, even next generational technologies, because of the way that Ansible is fundamentally built. Each component of its execution model is decoupled. It has a loose coupling, it has a contractual API where we can just implement a native protocol. We can automate. We have the potential. Let me back up before I say something that's going to get me in trouble because it's not officially supported. We have the potential to support and automate any device on any native protocol. By default, it will use SSH. It's, Ansible originally was, created to automate Linux systems. From there, we went to Windows. From there, we went to AIX and ZOS and Mac OS and various other things, networking devices. So we have, all the major networking vendors, things like that. And then from there, we took that idea and said, okay, well, what next? What is the opportunity to automate next? And that's where we landed on Industrial Edge. And what's so very, very fascinating about this is we have the ability to take this flexible, adaptable, pluggable technology and communicate to a device that doesn't talk over traditional networking protocols. So common industrial protocol for those who are familiar with industrial manufacturing. This is a way to actually talk to programmable logic controllers. The pictures that we had up on about the demos that we have, so each of the components that control a valve or a piece of the conveyor belt for the labeling system for the beer bottles, each of those has a programmable logic controller. And for those who aren't familiar, you could almost think about it like a microcontroller. So if you're familiar with like ESPs or Raspberry Pi, what is that? It's not the Zero, it's the Micro or something. I don't know. Just various other microcontrollers that you can adapt and interface with sensors and make decisions on, and it's very local. This is effectively an industrial version of that that's been around since, I think, the 70s. And we were able to take Ansible automation to that space and bring along the ability to take our common in-order task execution to accomplish tasks, to take all the power that everyone hopefully knows and loves about Ansible and apply that to a new space. And this was really, really cool for me to work on. So I wanted to quickly show a couple things that unfortunately, because of the contrast, don't show up particularly well here. But this is an example using the Allen Bradley brand from Rockwell Automation, where we are actually doing the Control Logic's programmable logic controller, and we're doing tag value for sine wave generator, and we're gathering existing config files. So these are examples of things that we have been told from feedback that are common types of operations that need to be done or would like to be automated in an environment in the industrial space that would need this. So this is using Ansible. So if anybody's ever written an Ansible playbook against a Linux host or a Windows host or a networking device, the playbook is the same. All we do is we set our hosts to the PLC control plane, because again, this can't talk IP. And it is over a device. So the way we do it is through a control plane, backplane interface. And so what we do is we connect into that backplane and then operate from there. Literally, it just gets down to sending hex codes and receiving the hex codes and kind of going back and forth from there. So the goal is to keep the simple to grasp language, the in-order task execution, bring concepts such as infrastructure as code to the operational technology space, and bring value there for the quickness to learn. So the next thing that I'm going to talk about is the Red Hat Device Edge, or RHDE. And Red Hat Device Edge is a combination of kind of a product offering that we're affectionately calling RHEL for Edge, and a edge optimized version of OpenShift called MicroShift. And it is a scaled down, pared down, more opinionated offering to be able to give that consistent deployment model. So if your developers are developing, and this wouldn't necessarily be for like the manufacturing floor as much. We see this in retail space and things like that. So it's kind of a different use case. But you never know. I mean, it's entirely possible this is something that you would want for that deployment model. But you have your developers developing in OpenShift, and maybe you're using the new developer hub, or maybe you're already utilizing what you have today, and this gives you the model to be able to take that application and then deploy it out to your edge with a one-to-one. The other option is, because RHEL for Edge is RHEL, you can package it up as RPM or just deploy it as a binary payload if, I don't know, you don't like version control or transactional models for updates. But what's interesting about RHEL for Edge is it uses a technology called RPMOS tree. An RPMOS tree has the ability to do immutable transactions. So the upgrades are immutable. And the way that I define this is, for those of you who are Linux systems administrators, if you run a DNF update or a yum update and you're in the middle of updating glibc or letting Dracket compile a new VM in Linux, and you kick the power out from the system, does it reboot? It's Schrodinger's server. We don't know. That scenario cannot happen with this. The way that this happens is it's either an all or nothing. If the update is not complete, you get nothing. If it is, you get something. And it's a delta. So it's effectively Git for binary trees of binaries, things like that. So what we did is you have the ability to kind of separate where the operating system ends and where your application begins. So you have that separation to be able to say, okay, I will lifecycle manage my operating system this way, and I'll lifecycle manage my application this way, and that gives potentially some separation. Or you can lifecycle manage them all together. That's all an option, and everything, because of the nature of containers. Containers are almost fully atomic in upgrade. There are still fair scenarios that are possible, but the operating system is a fully atomic upgrade. And then we created Ansible Automation to automate the entire end-to-end scenario of this. We can build it all, we can deploy it all, and then we can also automate and lifecycle manage it from there, as well as repository manage the content that you've built. And the best part, you can make your own bespoke operating systems using this tooling. You can specify what gets put into it, so it's effectively it's a recipe and a cooking procedure and the appropriate tools in the oven to bake a custom RHEL. It's all built using RHEL bits. What did I do? Oh, goodness. Oh, I accidentally right-clicked. Oh, come on. I did. I think I broke it. Here we go. Okay, so we created a few Ansible collections to do the stuff I was just talking about, and I realized I probably should have progressed my slides as I was talking. I apologize for that. So this is specifically the OS build. So the thing that I talked about, how you can do your own bespoke, curated, artisanally crafted operating system. This is that process. You have the ability to put inputs into a tool called OS build, which if you're a user of console.redhat.com and you have ever used Red Hat Image Builder, this is that. This is the same tooling. This is the on-premise version of that. And for anyone who is a RHEL customer, you get this. This isn't some add-on. You don't have to buy OS builds to be able to do this. However, you do need Ansible Automation Platform to automate the full process. You don't have to do all the bits and do the buttons and click the keyboard by hand. So this will bring you through the whole image build process. At the end, you will have an operating system that you can lifecycle manage, and then we also offer the automation to lifecycle manage it. And the big difference here is this diagram is very similar. The big difference is that we added microshift. So the reason we make the designation is because there's kind of a maturity journey in the world of your journey towards fully containerized and orchestrated containers. Is you either have no containers and you just have binaries, or maybe you're actually packaging RPMs. Okay, well, we can handle those two scenarios. Let's say maybe you have containers, but you haven't quite dipped your toe into OpenShift. You're not there yet, but you have an application, you've containerized it, you just want to run a service that happens to be running a container. Well, we did that too. We can also handle that. We can handle that via a partnership that we did with the RHEL engineering team for a RHEL system role that will handle Podman containers. So you can actually do a single Podman or a multi-container Podman deployment as a single service. So that way you can actually do system CTL, start, and manage it like you would a normal service. From there, we can add microshift. And you actually deploy microshift, and then we've not only made the automation to allow you to build and deploy microshift operating systems, but we can also do workloads. So we can also deploy the applications on top of that to deploy your workloads out to your edge footprint utilizing these technologies. So from there, it's just kind of slides. It's just about bringing this open source technology to the new space, to the industrial edge, and finding ways to automate it. Because with Ansible, that's what we're all about. We're all about automating everything. Thank you. Questions, comments, snide remarks? Bring it on. Preferably snide remarks. Yes. So you're saying because you have to do the limiter, you have to do the filter for each region to the execution node. Because now I have to start it every time for each execution node. We should be able to actually. Okay. There's not a built-in easy button for that today. We could make it work though with event-driven, to where the event could trigger each job template you need. And then assign to an execution. Yeah.
This is something I want to add more robustness to to the mesh.
With host files or something, we have a CMDB and there is pointed out where that system is. So Ansible can read that out, but now we have somehow to push that to an execution.
Yeah. This is Chad's job.
We actually are doing active work on mesh right now. Things like scheduling. Think about do I need the mic?
No, it's fine. The room's not that big.
That's fine.
Can you please repeat the question? What was the question?
The question was about if I have regional execution nodes and I need to start a job template, I have to start it for each region. One job execution won't automatically start it in every region. You have to, because of the fact that the job is set to a host pattern, and you have to filter down to get to the hosts on the other side of that execution node.
And some of the work that we're actually doing right now on Mesh, first we needed, the way that Mesh works today, it doesn't have as robust logging as it needed to be able to do things like that. So we actually just added that. I think that Aaron just pushed that. Now that we have that, we can actually start doing a lot more finite. And that's specifically for my request that if we have a store or a site lose connectivity, I want them to continue to be able to run any scheduled automation. So being able to schedule that execution to happen on a Mesh node is something that is actively being worked. But your request also could possibly be added to that because I think it would make sense. And this is why I love having things like Summit, because people smarter than me have really good problems to help us that need help solving. Thank you.
PLC version control, can you back up PLC loads and tell us if that's changed?
Oh, so he asked if we can back up PLC loads. So there are specific things that are done with the, I think it's XCD files that are backing those up that are proprietary. So no. Could it be done? Yes. That's something we're working on.
Yeah, I was going to mention, we're working with partners to try to make that possible. It's not right now because of the proprietary interface. Yep.
What about configuring set point changes? Can you do that?
Yeah, so the question was, can we do set point changes? And yes, we can. That one we can do, yes. Oh, you're okay, waving. All right, it's lunchtime. Thanks, y'all.